Okay, so we're going to switch directions now. We're going to talk about midpoints, okay? So we have 3 different vocab terms here to talk about. So the midpoint of a segment, the definition is a point that separates a segment into 2 congruent segments, okay? So just a quick demo. We've talked about congruent segments in section 1.2, okay? And just before I draw a picture, remember congruent segments are segments that have the same length, okay? So if we just quickly draw a segment, all right, and let's call this just P and Q. And then let's draw this midpoint in M. All right, so I'm telling you guys that M is the midpoint. So what does that mean? So if we go off of that definition, it says that it's a point that separates a segment into 2 congruent segments, which means then that these 2 segments, PM and MQ, have to be congruent. And if those segments are congruent, that means they have to have the same length, right? So if the length of PM was 10, what would be the length of MQ? It would also be 10, okay? Which means that the full length using segment addition of PQ would be 20. Now, let's get this theorem so that we can apply it. Okay, so let's first draw a picture. So let's go ahead and draw it. We can draw it within that box if you have space. I know mine's a little bit tight. All right, but let's go ahead and draw a segment AB. And then let's go ahead and put point M, all right, in the middle. And so what this prompt is saying is that M is the midpoint of AB, all right? And so if we know that, what's our conclusion? Well, we've already talked about it, but now let's write it out, all right, in geometry terms. Then we know that segment AM is congruent to segment MB. Okay, so if M is the midpoint of AB, then segment AM is congruent to segment MB. Now, once again, how do I notate that on my picture? I just use these little tick marks right here. Okay, remember those tick marks mean that they are congruent. Okay, so let's actually now talk about, though, how do we get that from a coordinate plane? So once again, let's plot some points, and we're going to then talk about like the general formula, and then we're going to apply it. So let's go ahead and plot the points this time. Let's do -6, 1. And then let's go ahead and do 2, -3. And then let's connect those. Okay, so what we need to do is we need to find the midpoint, all right, between those 2 points. So we have a formula for that, all right, and we're going to do it in a general formula. So once again, I want you to label -6, 1 as your x1, y1. And then for 2, -3, we're going to go ahead and label that as x2, y2. So our formula for this is, and I want you to write it out this way, because I know there's a question that we're getting to that it's helpful if you think about it this way. So we're going to call this MPX, and what that stands for is the midpoint x coordinate is equal to x1 plus x2 divided by 2. And then MPY, so the midpoint's y coordinate, is going to be equal to y1 plus y2 divided by 2. But then your final answer is, it's a point, so it's still a coordinate, right? Is going to be MPX, comma, MPY, okay? Okay, so let's go ahead and find the midpoint of the segment that we just drew. All right, so I asked you to go ahead and plot -6, 1, and then I asked you to do 2, -3. And just like in distance formula, I want you to go straight across and label these x1, y1, x2, y2. And now we're just going to go ahead and plug in, okay? So plugging in to our MPX right here, okay? I'm going to get MPX is equal to my x1, which is -6, plus my x2, which is 2 over 2. And then let's simplify that. Negative 6 plus 2 is negative 4 divided by 2, which gives me negative 2. Now let's do the same thing for my MPY. All right, so I have MPY is equal to, all right, my X or my Y1 is 1 plus my Y2, which is negative 3 divided by 2. I'm going to get negative 2 divided by 2, which gives me negative 1, which means that my final answer for this is negative 2, comma, negative 1. Okay. All right, so what I want you to do is I want you to pause, try example 4 on your own, all right, and then I will go ahead and rework it through, okay, and then play to make sure you got the final answer. So pause now, try example 4, and then replay it. Okay, so for example 4, let's go through x1, y1, x2, y2. Okay, we have MPX is going to be equal to my x1, which is negative 3, plus my x2, which is 2 over 2. Negative 1 plus 2 is negative 1 divided by 2, and we're going to just keep that as negative 1/2. Now let's do MPY. So we now have MPY is equal to, we have 6 plus my Y2, which is 10 divided by 2, which gives me 16 divided by 2. Final answer is 8. So then my final answer for my midpoint is negative 1/2, comma, 8. Okay. Now, example 5 is why I wanted you to write it with the MPX and the MPY. All right. So I want you to compare what we're doing on example 5 with what we've done with example 4. So if you look at example 5, it says y is the midpoint of xz. And then we're given the endpoint of z, but then we're given the point of y, and so this is our midpoint. Y is our midpoint, right? So if we just kind of visualize what we're doing, and this is not drawn to scale, okay, but if this is my segment, and I have xz and y, I'm given y and z, and now I need to find x. X is what I'm looking for. So we can't just plug in those coordinates into our formula, all right, because we have to solve for an endpoint now, okay? So follow along here. Here's what I need you to do, okay? I want you to label what we have. So remember that MPX stands for my midpoint x coordinate, which is this negative 2 right here, because y is my midpoint, right? So negative 2 is my MPX, and my 2 is my MPY. And then I'm going to label my z as x1, y1, which means that what I'm looking for my point x is my x2, y2. All right, this is what I'm trying to find, okay? So let's go ahead and write down our formulas again. So I have MPX is equal to x1 plus x2 divided by 2. And then I have MPY is equal to y1 plus y2 divided by 2. And let's look at what we have labeled. So do you see here how I have my negative 2 labeled as my MPX? That means I'm going to take this negative 2 and actually plug it in for that MPX. So I'm going to have negative 2 is equal to. Now my x1 I labeled as 2. Plus my x2 is what I'm looking for. So I'm going to keep it as x2 divided by 2. So now let's solve. So I actually have to get rid of this 2 in the denominator first, which means that because it's being divided, I need to multiply. So I'm going to multiply by 2 on both sides. And that's going to get this to cancel out, okay? So negative 2 times 2 is negative 4 is equal to 2 plus x2. And now to get rid of this 2 right here, I have to subtract it over. So I'm going to get my x2 is negative 6. And now I'm going to follow that same process, all right, for my MPY. So I'm going to plug in 2 here for my MPY is equal to, I labeled my 8 as my Y1 plus Y2 over 2. And once again, I have to get rid of the 2 on the denominator. So I'm going to multiply both sides by 2 to get that to cancel out. And I have 4 is equal to 8 plus Y2. And then subtract the 8 over. And I'm going to get, I'm running out of space, your Y2 is negative 4. Which means then that my final answer is a coordinate, correct? So it's x2 comma y2, which is negative 4 comma negative, I'm sorry, negative 6 comma negative 4. And that's your final answer. All right, so I'm going to pause there, and then we are getting really close, guys. I know it's really long, okay, but there's a lot of good stuff.